back to inverse. So suppose we have matrix A. If we have matrix B such that B times A is equal to an identity matrix, or A times B is equal to identity matrix. I mean, I can just actually put them together and write AB equals to B equals to I. So if we have this, then what we say is that B is an inverse of A. So basically, whenever we pre-multiply or post-multiply A with B, we get the identity matrix. And the same is true for B as well. Whenever we pre-multiply or post-multiply B with A, we get the identity matrix. Okay. So why is this important? Let's go back to this. 2, 3, 7, I think -1, x, y equals to 8 and 5. Okay, so let me just simplify this. Suppose I'm going to call this matrix A, matrix X is equal to D. Okay, so matrix A is this, matrix X is this, and matrix D is this. I'm going to write down the dimensions as well. Matrix A is 2 by 2, matrix X is 2 by 1, and matrix D is 2 by 1. That's not important. What's important is that, as we already saw, we cannot do this, X equal to D by A. We can do this in algebra, not in matrix. So what we do is we want to find the inverse of A. Okay, so if B is an inverse of A, what happens if we multiply both sides by B? We get B AX equals to BD. What we know is that BA gives us the identity matrix. So we have IX equals to BD, and IX, we've seen that when we multiply anything with the identity matrix, let me just go up and point that out here. When we multiply anything with the identity matrix, we get that matrix back. So as a result, what I get is X equals to B by D, B times D. And this is exactly what we wanted. Because remember, X is just, X is a 2 by 1 matrix. D was a 2 by 1 matrix. And B, we'll see Y, is a 2 by 2 matrix. And this is our solution to the system of equations. So what we have to do is we have to convert our system of equation into this form. Then we have to find an inverse for this matrix, and we're going to multiply both sides with that. And that gives us our answer. We're going to learn how to construct an inverse in the next lecture. But today, let's just talk about some properties of inverse. So the first property, important, not all matrices have an inverse. So only a few matrices will have an inverse. If a matrix has an inverse, it is square. What does that mean? Only square matrices have an inverse. Okay, so it's now being square, a 2 by 2 matrix or a 3 by 3 matrix or an 8 by 8 matrix, being a square is not a sufficient condition, it's a necessary condition. You have to be square to have an inverse. However, you may be square and still not have an inverse. Okay. So property 2 is that matrix and its inverse have the same dimension. Now here's the thing. For this course, if you just remember this property, it's sufficient. But it's also interesting to try and think about why this might be the case. Okay, so I'm not explaining it now. If you are interested, I want you to try and think about it and figure out why a matrix and its inverse must always be of the same dimension. It's quite interesting. And the third one is that an inverse is unique. What that means is that if a matrix has an inverse, it is unique. A matrix cannot have more than one inverse. All right. Okay. And a few more. Let's go through all of this. If we have inverse of A and we take inverse of that, we arrive at A. We have AB and we take an inverse, we get B inverse times A inverse. And the sixth one, if we have A prime, which is transpose, and then we take the inverse, this is the same as taking the inverse and then taking the transpose. So these are just relationships you guys have to remember. It's not that difficult. And this is it for today's lesson.